Hello friends, today we will see tips and tricks in C and C++. We will discuss about an important concept regarding constant character pointer. Let me to show you the program. This is the program. Here we are having two constant character pointers, that is hello, hello, same string. And here we are comparing P with Q. If these two are same, then I am printing this. I am okay, otherwise I am not okay. Think for some time, then come back to see the solution. Observe here. This is nothing but a string constant, right? This hello is within double quote is a string constant. By default, string literals are constants. Okay. So where memory will be allocated for this? It will be in some constant or read-only memory location, right? That we will see. Observe here, we are having two hello, okay? But in actuality, in memory, there will be only one hello. Okay, there won't be two hello. String literals are by default constant. Okay, we cannot change. Even if you are not writing const char star p, you are simply writing character pointer p equals to hello. You will get a compilation warning. Okay, and after that, try to change this string using p. You will not be able to do that because string literals are constant. Okay, if you run the program, output will be I am okay. Why is it? Because these are not two strings. In memory, there is only one string hello, and that hello is being pointed by P and Q. Okay, so P and Q are nothing but pointers storing addresses, and address of string hello is only one, right? Only one address. So that will be stored inside P and Q, by which here comparison is success. So we are getting I am okay. Now let me to show you. This is time to show you how this program is working. Let's see the plan. First we will build and run and verify our program. Then we will see where constant string stores in memory. And after that we will see if we print address of hello, would it be same? That means P is storing address of hello, Q is storing address of hello, and here inside printf we will intentionally print address of a string hello. Okay, here we will write printf percentile p, then within double quote hello. Okay, that we will see. Let me to show you the program. Okay, this is the program. Okay, same program. Let's do a gcc main.c. Okay, a.out. Fine. Now our output is I am okay. Why this is I am okay? Because P and Q are pointing to same memory location. If you'll see the memory location, we will have only one hello in the memory. Okay, and P is pointing to this, as well as Q is also pointing to the same memory location. Okay, there won't be multiple hello present in the memory. Okay, you just think, suppose we are having 5 or 10 string hello inside our program. Do you think it will be a good idea to reserve 5 different spaces for the same string hello? Definitely no, right? Definitely no. So our compiler is also doing the same thing. Okay, if string is written hello or something, so this string literal is constant, so it will go to a constant memory location. Okay, now let's generate the assembly for this program. Okay, main.c -s. Now see main.s. How many hello are there? Here see there is only one hello, right? And this is also in read-only memory location. Here see all the strings are there. I am okay, I am not okay, everything is there. But it is unique. Okay, it is unique. Suppose here we are printing value of p. Okay, let's print the address. Then here intentionally I am printing address of string hello. Let's see the behavior. gcc main.c ./.out. Now see, both of these two addresses are same. Observe here. This is value stored inside P, right? P is pointing to hello. If you are printing Q, Q will also print the same thing. If I am intentionally printing one string hello address, that is also same. Here see, it is also printing the address of hello, right? That means in memory we are having only one hello. Okay, there is no multiple hellos present in the memory. Okay, that is the reason for which p equals to q is true, and it is printing I am okay. I hope you understood this. Okay, let me to show you the assembly for this. Now see, there is only one hello. This is the assembly code. If you will search for hello, we will get only one hello. Now see, only line number 5 we are having hello, and it is also in read only memory location. Okay, this string cannot be changed. Fine, let's convert this to C++. Let me to do one thing. Let me to copy main.c to main.cpp. Now let's modify main.cpp. Okay, cstdio, other things are same. G++ main.cpp -o cpp out /cpp out. Fine. See the output here. Fine. Where const string stores in memory. This part is over. This part is over. But where exactly this is storing, that I am going to show you. Okay. Now what we will have to do? We are having two. This a.out is C binary and this one is C++ binary. We can take any of these two. Both are same. A.out. Now see, text segment, or this is code segment. This is this much. Data segment is this. BSS is this. Okay. If we are saying YYP, we are adding a new instruction in this main.c file. Okay. Now this is C file. Okay. Let's build it. Main.c. Okay. Now measure the size. Now see, this text segment is increased. But is there any change in the data segment? Data and BSS? No, it is not. Right? That means this constant string, it is going to our text segment or code segment. Okay? If you will do gcc hyphen no optimization. Now let's see. Let's say there is no optimization. No, we are not doing any optimization and generating the assembly. Let me to show you what is happening. Okay, this is our assembly code. There is no optimization. Okay, hello, I am okay, everything is here, right? Okay, all these strings are here. But if I am applying optimization here, not 0, might be 3, 4, whatever, then what is happening? See, now see, hello is there, but what about not okay? Are you observing? What about I am not okay? There was one string, right? I am not okay. Here, where is this string? This string was present previously. Okay, if you want, I can show you again. But this string was present. I am not okay. But now see, directly in assembly itself, it is decided that p is equals to q, and this instruction needs to be executed. So here only I am okay is here. I am not okay is not here. Okay. I am not okay is not here because we applied the optimization level 3. Okay. I hope you understood why we are getting I am okay. Suppose here I am saying X. Write it. Now let's build it. See the assembly. Okay. Optimization we applied, right? That's why this X hello will not come. So what we'll have to do, just no optimization. Now if you will see here, see X hello, these strings are present. If you are not accessing P here and hello here, then also this will not come here if you are doing optimization. Okay, so let's do that also. Let me to delete this. I am okay, I am not okay. Right. Without optimization, that you know, hello string will come. Now see, without optimization, you know, hello string will be present in the assembly. But with optimization, this is O3. Now see, if I'm searching hello, see, hello is not here. Hello string is not here. It should present here, right? But it is not here because of this optimization. I hope you understood what is this O3 O0 optimizations are. Okay, and also you understood where this constant string stores in memory and why this p equals to q and why we are getting I am okay as the output. Fine. I hope we have already done all of these three action items. Right. Thank you.